In this question, we are given that there are two charges having equal charge Q and equal mass M. They are separated by a very large distance. One charged particle is thrown towards the other charged particle with a velocity v. We are asked to find out what will be the minimum distance between these two charged particles during this motion. So let us find out what is the minimum distance during this motion. Now what will happen is, when it is given velocity towards this charge, since both the charges are identical, so they will exert repulsive force on each other. This will experience force in this direction and this will force experience in this direction. So it will start moving towards right and its velocity will start decreasing. Initially there exists a velocity of approach, since it has no velocity initially and it has velocity towards this, so the distance between them will decrease. But its velocity will keep on decreasing, its velocity will keep on increasing. At some instant of time, their velocities will become equal. Let us call this velocity v dash. So before this instant, if I'll call it particle number 1, particle number 2, before this instant, velocity of 1 was larger, velocity of 2 was smaller, so they were approaching towards each other, the distance between them was decreasing. But when their velocity becomes equal, then after this moment, since 2 is still experiencing force towards right, it is experiencing force towards left. After this moment, velocity of 1 will start decreasing, velocity of 2 will further increase, thereby the distance between these two charges will increase, will start increasing, and this is the moment when the distance between them will be minimum. At this moment, the distance will be minimum. This can be explained mathematically also, because when R is minimum or maximum, at that moment of time dr by dt should be 0, means at that moment of time the relative velocity of these two particles should be 0, or you can say the approach velocity should be 0 or separation velocity should be 0. This is the meaning of dr by dt, and their velocities are same. So at this moment dr by dt is 0, hence at this moment R must be either minimum or it will be maximum. Since distance was decreasing, so it should be minimum. So that is how we have proved that when their velocities are becoming equal, at that moment of time the distance between these two particles will be minimum. Now how to find out this distance? In this diagram we are having two unknowns. They are v dash and r. So we need two equations to find out the value of r and v dash, and those two equations are: apply linear momentum conservation from initial to this position. So from initial moment to this final position, if we apply the linear momentum conservation, then we get mv plus 0 equal to mv dash plus mv dash. This is equation 1, and from this equation we can get the value of v dash. Now by energy conservation, initially kinetic energy is half mv square. The first particle has this kinetic energy, second particle has 0 kinetic energy, and the electric potential energy is 0 because the distance is infinite. This must be equal to half m v dash square plus half m v dash square plus kqqq by r. This kqqq by r, as you know, is the potential energy of these two particles when the separation between them becomes r. So we have these two equations. By putting the value of v dash into equation number 2, we can get the value of r. This r will be the minimum value of the distance between them, and this will be the answer of this question.